Alright, so now for part 2 of the earthquakes lab, we're going to be looking at a second epicenter location problem. In this case, it's one for the 1989 Loma Prieta earthquake. And you'll see that we're going to have 3 different stations, station A, B, and C. And your job, again, is to locate the first arrival of the P wave and the S waves, just like we did in the previous problem. Record those here. In this case, I have S wave first, so it'll be easier to subtract the bigger value from a smaller value here to get the interval. So you'll do that for that one, and you can do it either the way I showed you on the file here online, or you can do it on the printed copy as well. And then but the only difference for this exercise is that we're using kilometers, right? So now you're going to need kilometers. So if you do the Google Earth exercise, make sure you switch from miles to kilometers, right? For this problem here. And then if also for the scale, so this is in kilometers, you want to make sure you plot these in kilometers. And so the 3 stations we're using, A, B, and C, also have their latitude and longitude. You're going to plot those on this map here. Note that the distance is in kilometers. And be careful when you're plotting this. So remember, like 121.5, or actually let's look at this, 114.5, station C, and 41 north. So 41 north would be, so here's 40, 42, so 41 is here, and 114 is here. Remember that as you go farther west, the numbers get bigger. So 114.5 should be right in here, because that's 115 there. So 114.5 and then 41. So station C should be right here. So be careful when you plot those, because if you don't get the location right for the stations, then you will not get the epicenter correct. So be careful with that there. Then again, you'll locate the latitude and longitude of the epicenter based on where all 3 are coinciding. This last part deals with earthquake intensity. And remember, intensity is based on 3 factors. How the magnitude of the earthquake, was it a magnitude 4 or a magnitude 7, right? Obviously, more shaking and more damage done during a higher magnitude earthquake. How far were you from the epicenter? The farther from the epicenter, the lower the intensity, the lower the damage. The closer to the epicenter, the higher the damage. Although some places can be pretty far from the earthquake and still experience high damage, high intensity. And that's because the bedrock in which those buildings, it could be loose, unconsolidated sediment, it could be sediment that gets liquefied and experiences liquefaction, or it could have landslides. So again, the nature of the bedrock. In my lectures, I talk about how unconsolidated sediment, mudstones, shales, they're much weaker and they shake more violently during an earthquake than metamorphic rock or igneous rock, which is a harder, more compact rock. So those are the reasons why we can see high intensities farther from an epicenter. And so what we'll be using is something called the modified Mercalli scale. And in this lab, I have all the different descriptions or values for the amount of damage done at each of these Roman numeral values. It goes from 1 to 12, where at 1, pretty much nobody really feels it, to where there's high destruction and near total damage when you get to these higher values over here. And so your job is, for this first part here, there were questionnaires sent out after the 1989 Loma Prieta earthquake, and when those surveys were returned, geologists compiled them into 5 categories or 5 groups. And those 5 groups are stated down here on this survey table, and I have that table down below here. So you can see Group A, everybody felt it, they were all frightened, people had trouble driving, and then for people in B, well, they also felt it, there was some collapse, there was some other things going on here. So what happened is you want to use these descriptions and compare it to the modified Mercalli scale. For example, if you think these people A, concrete building, gas, ground cracked, some buildings collapsed, so that looks like it could be maybe an 8, people frightened, damage slight, maybe an 8 or a 9, right? So you would put that value. So again, read more carefully. I'm just estimating. You would put that modified Mercalli value here, or all 5 of these questionnaires. Then the next thing you'll have to do is you want to draw these isoseismals. So isoseismals are like contour lines. The areas, or the contour line will outline areas that experience equal amount of shaking or intensity. And so, for example, you can see the Loma Prieta epicenter was somewhere in the Santa Cruz Mountains, but you can see you have B's up in here. So you would sort of draw a circle around where all the B's are and make some sort of contour line in here where all the B's are. Kind of exclude this C here. Then as you go farther away, you would divide between the C's and the D's, right? So you would have a line going between the C's and the D's here. And then, although over here there's some A's and B's, which are you might have to make some other little isoseismals in here. So something else is going on over here. And then, so basically you're making this contoured map. So here's an example of one of those isoseismal maps for an earthquake up here near Montana, Wyoming here. And you can see that here the star represents the epicenter, and then you can see that there are modified Mercalli values of 6 right around the epicenter. So there's one isoseismal. Then areas out over here experience of intensity of Mercalli scale 5, so they got another. So it's almost like a contoured map, and you can see that the farther you go out, these are intensities 3s, 4s, 5s, 6s, right? So you kind of make this ice. And then there's some outliers over here where maybe there was weaker rock that shook violently even though it was farther away. Anyhow, this is what you want to do on this map right here, right? You'll make a contour line based on the intensities that you determine from these interviews. Now, finally, the last part is we're going to look at a really old earthquake here, one from 1872, before we had seismometers and seismic stations. But we can use people's description of the amount of damage done to try to figure out where the epicenter was. So again, we're going to draw the contour lines or the isoseismals here, and then we're going to, so for example, they've already given us the intensities here. So you can see that you got some 6s here. That might be the highest. Oh, here's a 7. So it looks like the 7s might, so you might draw an isoseismal around here, which means the epicenter is going to be somewhere in this region here. So you would mark that with an X. And then that would be it. So that's the end of the lab here. And so again, we'll see how far you get along here, and I will help you on this later during lab, and so will Frida.